everyone, I'm Henry J. Tejos and I'm here to present the solution of 12-29 of Chapter 12 of the said book. Hope you understand. And here is the given of the said problem. First, we need to know the balanced redox reaction by combining the half reactions of AS2O3 and MnO4. And we will get this redox reaction. Then, we need to know the weight of AS2O3. Through multiplying the volume of the second portion, which is 3.60 ml, by the equivalent, which is 0.005934 grams AS2O3 per 1 ml. Calculating this, you will get 0.0213624 grams. There. Next is, we need to know the millimole of this said drug. Which would be multiplied by 1000 because of millimole. Over its formula weight. The formula weight of AS2O3 would be 197.84. Computing this, you will get an answer of 0.10797814642. Outside and will be cancelled, so it will be in millimole AS2O3. Then after that, you can get now the millimole of MnO4 through the reaction. Multiplied by, since the number of millimole of AS2O3 would be 5, would be placed here. Over its ratio with the MnO4, which is 4. Then calculating this, we would get 0.0 cancel, you will get the millimole of MnO4 minus. There you go. Then, since you have the millimole of MnO4, the concentration of KMnO4 would be the same as the concentration of MnO4 since they have 1:1 ratio. And since molarity is equal to mole over liter, it can be millimole over the milliliter. Then, 0.0868 over the said volume of MnO4, which is 3.60 ml for the second portion. And calculating this, you can get again of MnO4. Then, after that, already have the concentration of potassium permanganate. Next, from the ratio of Fe2O3 to the iron itself, iron 2 plus, which would have ratio of MnO4, which would be equal to, as said in book, Fe having 5 iron would be equal to 1 MnO4. But since you have 2 iron here, you would multiply both the sides to 2. So it will be 10 iron 2 plus and 2 MnO4. Since Fe would be 10, then you would put a coefficient of 5. And now, having the ratio of the 3 compounds, we can get we can now get the mass of the Fe2O3. Since the ratio of the MnO4 to the Fe2O3 from the last ratio would be 5:2, whereas the 5 millimole of Fe2O3 would be equal to 2 millimole of MnO4. Multiplying it by the formula weight of Fe2O3 This part is the formula weight of the Fe2O3. Then you will get an answer of there. You now have the mass of Fe2O3, and you can now use this as your numerator for getting the percentage of Fe2O3. So, percent Fe2O3 be equal to 0.3449 grams Fe2O3 all over the weight sample, which was 0.5000 grams of the titanium ore. And since this sample is divided into two equal parts, then we will divide this into two because it is only the second portion, and multiplied by 100 to get the percentage. Solving this, we can now get an answer of 13.7953% of Fe2O3. Now have the first compound, which is Fe. Next, we would like to get the percentage of TiO2. We can get the percentage into a simple formula. Whereas the first volume from the first portion would be subtracted by the second portion, which is 11.60 ml minus 3.60 ml. Then, since it is in ml, we can now divide this into 1,000 for a simpler formula. And then, we should multiply this by the concentration of MnO4. There you go. Then, this full equation would be multiplied five moles of titanium over 1 mole of MnO4. How did I get this? We should have a balanced equation of titanium and MnO4. We would get this through then this would be the reactor. And from there, we can now multiply it by the formula weight for that would be the ratio of 5 Ti to TiO2. Then multiply by the formula weight of TiO2, which is 79.866 grams per 1,000 to the millimole, multiplied by the 1 mole. By calculating the answer, by calculating this, you will get an answer of 30.68% of TiO2. And there. We now get the percentage of TiO2 and the percentage of Fe2O3. Hope you understood it.
From the following data, find the percentage of Fe in a sample of crude ferric chloride weighing 1 gram. The I2 liberated by the reaction 2FeCl2 plus 2Hi yields 2HCl plus 2FeCl2 plus I2 is reduced by the addition of 50 ml thiosulfate solution, and the excess S2O3 is titrated with standard I2 requiring 7.85 ml. 45 ml I2 is equivalent to 45.95 ml Na2S2O3, and 45 ml arsenate solution is equivalent to 45.27 ml I2. 1 milliliter of arsenate solution contains 0.05160 gram AS2O3. It's given there that the weight of ferric chloride is 1.00 gram, and the I2 is liberated in this reaction, and it is reduced by the addition of 50 ml Na2S2O3. The excess S2O3 is titrated with 7.85 ml I2 with an unknown solution. And by balancing redox reaction, we can get this. 2AS2O3 plus 12OH minus plus 3I2 yields 4ASO3 3 minus plus 6I minus plus 6H2O. First, we will get the molarity of arsenite solution. So, ASO3 3 negative is equals to, we have to convert the given weight of AS2O3 into moles. So 0.05160 gram AS2O3 times mole over grams, 1 mole AS2O3 all over formula weight of AS2O3, which is 197.84 grams, times, which is, as you can see here, it is 4 moles ASO3 and 2 moles AS2O3. So 4 moles ASO3 3 minus all over 2 moles AS2O3 all over 0.001 liter. You can put 1 here. If we compute this, we can get 0.052163364 mole per liter. You can cancel. Mole per liter ASO3 3 negative. Ang gulo. After getting the molarity of arsenite, we will get now the molarity of iodine. It's stated in the problem that iodine has 0.045 liter. We will multiply that to the molarity of arsenite, which is 0.052163364 mole ASO3 3 negative over 1 liter times 3 moles I2 all over 4 moles ASO3. We got that in the redox reaction. Where is it? Here. 3I2 4 ASO3 3 negative, and we will multiply it to 1 over 0.04527 liter. If we compute that, we will get 0.038889187 mole per liter I2. After getting, this is the difference of 50 ml and minus 45.95 ml and A2S2O3. For O6, 2 negative plus 2I negative plus S2O3, 2 negative. And this S2O3, 2 negative, is the excess. And this weighs 45.95 ml. And this is 45.00 ml. S2O3, 2 negative plus I2 yields S4O6 plus I negative. So, we will 2 negative. We will balance it by adding two as coefficients of S2O3, 2 negative and I negative. So, this I2 is standardized. Now we can compute the molarity of S2O3, 2 negative. This equals to the molarity of I2, which is 0.038888917 mole I2 all over 1 liter times the volume 0.0785, the volume of I2, the volume which is needed to titrate, times 2 moles S2O3, 2 negative all over 1 mole I2 times 1 liter over 0.00405 liter is equals to 0.150755617 m S2O3, 2 negative. How do we get this? Then now we can compute for the molarity of I2. Volume I2 multiply the molarity of S2O3, which is 0.150755617 mole isosulfate all over 1 liter times 1 mole I2 all over 2 moles S2O3, 2 negative, over 0.045 liter. The computation, we can get 0.076969117 MI2. Now we can compute the percentage weight over weight. Percent weight over weight is equals to 0.045 liter. This is the volume of I2 times 0.076969117 moles I2, the molarity of I2, times 2 moles FeCl3 over 1 mole I2 times 1 mole Fe all over 1 mole FeCl3 times formula weight of Fe, which is 55.85 grams Fe, the atomic weight 1 mole Fe all over the weight sample, which is 1.000 gram FeCl3 multiplied by 100%. We can get 38.69% Fe.